have discussed what is the fuel cell, that converts the chemical energy that generated from the fuel into the electricity. So now we discuss the type of fuel cell. What are the types of fuel cell? Here we are having the various type of fuel cell. One is the polymer electrolyte membrane, PEM fuel cell. Next is methanol fuel cell. Third is alkaline fuel cell. Fourth is phosphoric acid fuel cell. Then molten carbonate fuel cell. Then solid oxide fuel cell, biofuel cell, reversible fuel cell. So one by one we will discuss these cells. First is the polymer electrolyte membrane, PEM fuel cell. What is this PEM? Polymer electrolyte. As the name suggests, it uses the electrolyte in the form of the polymer membrane. So polymer electrolyte membrane fuel cell are the low operating temperature fuel cell consisting of polymer membrane as the electrolyte. It means this fuel work at the lower temperature. So as the polymer membrane conduct hydrogen positive ions, PEMFCs are also termed as proton exchange membrane FC fuel cells. So it is also a proton exchange membrane cell. So they are use hydrogen or the low molecular weight hydrocarbons as a fuel at anode side and the oxygen oxidizer at a cathode side. Hydrogen at the or the low molecular weight hydrocarbons at the anode side or oxidizing agent at the cathode side. So among others, hydrogen being one of the potential futuristic energy sources and is the key fuel for the PEMFCs. Moreover, apart from the hydrogen based PEMFCs, methanol based, namely DMFC, have been supplied thoroughly due to their feasibility for the small scale portable application, means that can be used for a portable purpose also. So in principle, the both of these cells have the similar structure. Present study is focused on the hydrogen based PEMFC due to their prospective application potential in the domestic stationary as well as the portable devices, public transport, etc. So we use the hydrogen and it is having the low cost also. So hydrogen is oxidized at the anode to produce the hydrogen atom, as the function is the same. The oxidizing hydrogen is oxidized at the anode to produce the hydrogen atom, which migrate through the PEM to the cathode, that is a polymer membrane. It will go to the cathode and reduction of the oxygen takes place at the cathode to form the O2 negative ions, which combines with the hydrogen ion to form the H2O, and this develops a net cell potential that equal to the difference between the electrochemical potentials of the hydrogen oxidation reaction and the oxygen reduction reaction. So these connected to an external load, the constant current can be drawn if the reactant gases are supplied and the reaction product H2O is removed continuously to maintain the system in the steady state. So in the figure we will see that the hydrogen and oxygen PEMFCs with various components like bipolar plates with flow channels, gas diffusion layer and the membrane electron assembly. So membrane electron assembly is a part of fuel cell that consists of the cathode and anode catalyst layer. So the PEM itself, each of these components are use of the different material based on their particular functions, like practical FC consists more component for continuous power generation. So we can have it has to perform a number of tasks such as supply and transport of the fuel and oxidation to the appropriate electrode, removal of byproduct, electron transfer to the external load, hydrogen ion transport through the membrane, and the proper humidification of the membrane, moreover maintaining the temperature at an optimal level. So these are the various points which we have to keep in mind. So for high power generation, fuel cell units are stacked in the series by using the BPs. So FC stacks other auxiliary components such as humidifiers, heat exchanger, compressors, heating systems may required to just make the high power generation, and it must be in the series. Now you see that this is a one type of the fuel cell. You can easily see that at the membrane we are having a ion and cathode and anode. Load is attached here, catalyst layer is supplied to the system, and air is supplied, hydrogen is supplied at the one end to the anode. So in this manner this fuel cell is work. Now it is also the another PEM type of the catalyst layer just drawn on the system. Now you can see here that we are having a first the membrane in between that, with the membrane we are having a catalyst, then gas fuel layer is there, after that there is a gasket, after the bipolar plate, then at last it is a interconnector that must be connected and just supply the energy. So this is the schematic diagram. So it consists of outer plate, spacer plates, silicon gasket, end plates, gas diffusion layer, catalyst layer, polymer electrolyte membrane, and the gas connection. So these are the various form and that can be done and can be seen. So methanol, another is the methanol fuel cell. What is this cell? It is similar type of the fuel cell, and methanol fuel cell consists of the two electrode like anode and cathode, which are separated from each other through an electrolyte. So the electrode are conductive for the electron, while the electrolyte is only permeable for the positively charged hydrogen atom. You can see here this is the membrane, and this type of diagram is used for the methanol fuel cell. So you can see left hand side is a anode, right hand side is a cathode, and here there is a membrane in between that MEA methanol. So there is a current collector, moreover heating plates attached here with, and these are the end plates are also attached after the current collector, and there is a carbon plate in between the current collector, and in after current collector there is a end plate and then heating plate are attached here with. So this is a schematic diagram of the methanol fuel cell. So typically methanol fuel cell systems build on a polymer electrolyte membrane, and in terms of the design a distinction can be made between the two modes of the operation. Number one is the fuel cell that use the methanol directly, those that use the methanol indirectly. So methanol cell can be divided into two types. First is the direct methanol cell and another is the indirect methanol cell. So direct methanol cell are the most common form of the methanol cell. Compared to the other methanol cell, they are characterized by a simple system design and fast startup time. Methanol is directly supplied to the system, and they are usually having the low power system with an output of less than 200 watt. So So, we can have the electrical efficiency 20 to 30%, operating temperature 70 to 90 degrees centigrade, and reaction is just we are having a methanol. So, 2CH3OH plus 3O2, that is 4H2O plus 2CO2. What is the design and principle of this cell? She supply a methanol water mixture at a anode side. So, the mixture is split into a hydrogen and a carbon dioxide. So, the catalyst, that is the platinum we use, divides the hydrogen molecules into the positive charged hydrogen atoms, protons, and these hydrogen protons pass through the electrolyte and that proton exchange membrane, and that cathode, and then to the cathode, towards the cathode, and they react with the oxygen to form the water. And this process takes place at a comparatively low cell temperature of about 70 to 90 degrees centigrade, which enables the fast startup time. You can see here, this is the methanol fuel cell, and you can see there is electrolyte, anode and cathode. Carbon dioxide is passed through the membrane, and you can see on the other side there is a oxygen that it will convert the hydrogen atom into the ion. What are the application of this direct methanol cell? That is commercially and the private setting. So, the field of the application include the remote monitoring situations, video surveillance and systems. We can use the fuel cell directly, we can attach the cell and it will work. After that, for the smaller electrical system in the traffic control, mostly with the demand of power of the less than 150 watts. So, in the laser sector, DMFC are used for the on-board power supply in the boards and the kernels. Moreover, another is the indirect methanol cell, that is the IMFC or RMFC cell. That indirect methanol fuel cell, also called the reformed methanol cell, and that is why it is written as RMFC, reformed methanol fuel cell, and that uses the hydrogen as a fuel. The hydrogen is extracted from the methanol in a pre-process. So, this system design allows for the higher power output and improve the electrical efficiency as compared to the DMFC, because here we are supplying the methanol after the pre-processing. So, electrical energy here, electrical efficiency of this cell is 35 to the 50%, and operating temperature depending upon the membrane may be 70 to 90 degree or the 160 to 200 degrees centigrade. It means it work on the low as well as the high temperature. So, reaction here CH3OH plus H2 is 3H2 plus CO2, that is a reformed, 2H2 plus O2, that is a 2H2O, that is the fuel cell. So, design and principle similarly it differ with the regard of their membrane only. Some system use the conventional low temperature polymer electrolyte membrane, while others use the high temperature polymer electrolyte membrane. The difference is the membrane or electrolyte which we are using in between the cathode and the electrode. So, on the basis of this application for the low, we use the low temperature polymer electrolyte membrane, or if we require the high temperature, then we use the high temperature polymer electrolyte membrane. However, the basic principle is similar. First step, methanol is converted into the hydrogen containing the gas, that is reformate gas. This called the steam reformation process takes place at a temperature 200 to 200 degrees centigrade. In the contrast of DMFC, no watery methanol is led to the anode, but the gaseous hydrogen we use. So, however, since LTBEM, a fuel cell type commonly used the automotive industry, where we are having a low temperature, require the high purity hydrogen, the reformate gas must be purified before being used for the power generator. That is why the pre-processing has been done for this, as we require the purified gases. So, this may be accomplished by means of the palladium membrane. So, in this we use the palladium membrane. So, in contrast to the LT and HT PEM, and these are tolerant to the impurities in the reformate gas due to their elevated operating temperature. So, the step of conditioning is therefore not required for the system design. Now, you can see it is an indirect methanol fuel cell. Here again the system is same, but what we have replaced? We replaced the membrane, that must be of the, and the reform. You can see from the left hand side that the first the purification is done of the methanol, then it will going inside the anode part of the hydrogen is going towards the anode part of the system. So, here the you can see that there is a hydrogen rich reformate gas. So, this reformer is put before the fuel cell, so that first it will purify carbon dioxide by using this, then it will go to the anode, then electrolyte is there, then electrolyte again for as per the requirement high or low temperature, then it will work. So, reformation is required in this cell. What are the application? As are used for the stationary power generator, it can be used in the stationary power generator as well as in the automotive sector. Field of application include the remote telecommunication sites, backup power supply for critical infrastructure system, and modulus. Moreover, where we require the 150 watt of the several hundred kilowatts depending upon the field of its application. Another type of cell is a alkali fuel cell. What is this alkali fuel cell? That operate on compressed hydrogen and the oxygen. Now, compressed hydrogen, the generally used a generally used a solution of the potassium hydroxide, that is chemically KOH, in water as their electrolyte. So, efficiency is about 70% and the operating temperature is 150 to 200 degrees centigrade, right. So, cell output range from 300 watt to the 5 kilowatt. Alkali cell were used in the Apollo spacecraft to provide both the electricity and the drinking water. They require the pure hydrogen fuel. Moreover, however, and their platinum electrode catalysts are expensive. So, like the container filled with the liquid can be leak. So, you can see on the screen that this is the cell, and here you see that the working is same, as there is a hydroxy ions in between the anode and cathode. Load is attached the anode and cathode, electron flow takes place, alkali fuel cell, and where hydrogen and water is supplied towards this anode. There is a conversion takes place, and then we can get the conversion of the electricity. Another type of the fuel cell is the molten carbonate fuel cell. Molten carbonate use the high temperature compounds of the salt like sodium and potassium and magnesium that use the salt carbonates as the electrolyte. Efficiency ranges from 60 to 80% and operating temperature is about 650 degrees centigrade or 1200 degrees Fahrenheit. Units with the output up to the 2 megawatts have been constructed, and design exist unit up to the 100 megawatt. So, you can see here this is the molten carbonate fuel. So, you can see electrolyte here, the carbon trioxide ions has been produced inside the electrolyte, and then we can get the molten carbonate fuel cell because of the carbon trioxide ions. Now, it is having a high temperature that limits the damage from the carbon monoxide poisoning of the cell, and waste heat can be recycled to make additional electricity. So, their nickel electrodes catalysts are inexpensive compared to the platinum used in the other cell. So, in this cell we use the nickel electrodes. Moreover, there is a combustion of the carbon monoxide that is inside the cell. Now, but for the high temperature also limit the material and the safe use of the MCFC. They would probably be too hot for home use. So, also carbonate ions from the electrolyte are used up in the reaction and making necessary to inject carbon dioxide to compensate the temperature. Another type of the fuel cell is the phosphoric acid fuel cell. Phosphoric acid fuel cell use the phosphoric acid as a electrolyte. Now, efficiency range from the 40 to 80% and operating temperature between the 150 degree to the 200 degree centigrade. So, existing phosphoric acid cells have output up to the 200 kilowatt and 11 megawatt units have been tested. And this type of cell tolerate a carbon monoxide concentration of about 1.5% only, which broadens the choice of the fuel. They can be used for a various circumstances. So, if the gasoline is used, the sulfur must be removed from the system. Platinum electrode catalysts are required in this system, and the internal part must be able to withstand the corrosive acids. So, you can have here the phosphoric acid and the PEM fuel cell. Now, this is very electrolyte here. This is very simple that we are having the hydrogen. Now, you can see at anode side only the hydrogen is supply. After that, at the anode cathode side oxygen is supply. Then hydrogen ions then pass through the water. So, proton exchange membrane fuel cell work with the polymer electrolyte in the form of thin membrane sheet, that efficiency is 40 to 50. Now, this is the proton exchange membrane cell whose efficiency is 40 to 50 and operating temperature is 80 degrees centigrade. So, output is in the range of 50 to 200 kilowatt. The solid flexible electrolyte will not leak or crack, and these cells operate at a low enough temperature to make them suitable for the home and cars. But their fuel must be purified, and a platinum catalyst is used on both the side of the membrane, and which raising the cost. Cost is raised because of the platinum we are using. Another type of the cell is the solid oxide fuel cell. This type of cell use a hard ceramic compound of a metal oxide as a electrolyte. These cells which we are discussing are classified on the basis of its electrolyte. What electrolyte is using? On the basis of this, these cells are electrolyte. Moreover, these cells work in the different temperature conditions. So, on the basis of that, we can also differentiate these fuel cell. So, efficiency of this cell, solid oxide fuel cell, is the 60% and operating temperature is about the 100 degrees centigrade, and the cell's output is 100 kilowatt. Up to now, we have seen that we are having the various degree of the temperature in which this fuel cell can work, and moreover we are having the cell output at a different form we are getting for the different type of the fuel cell. So these fuel cell can also be classified on the basis of its output or the operating temperature or the electrolyte we are using for this, or the basis of efficiency also we can differentiate this type of fuel cell. Now at such high temperature, a reformer is not required to extract the hydrogen from the fuel, and waste heat can be recycled to make additional electricity. So, however, the high temperature limits application of SOFC units and they tend to rather larger, while solid electrolyte cannot leak, they can crack. So, you can see here there is a oxygen ion in between the membrane. You can easily compare this cell with the others also. And there is a proton exchange membrane cell. Proton exchange membrane cell use a water based acidic polymer membrane and it's as its electrolyte, and with platinum based electrodes. Platinum based, it means it is a costly. So, PEMFC cell operates at relatively low temperature, below the 100 degrees Celsius, and can be tailored electrical output to meet the dynamic power requirement. So, due to relatively low temperature and the use of metal based electrode, these cell must operate on the pure hydrogen, and these are leading technology of the light duty vehicle, material handling, and to lesser extent of the stationary and other applications, and sometimes these cells are called the polymer cell. So, this is the proton exchanger cell, and this is again the simple. Here you see that the hydrogen is supplied to the system, one side anode and the cathode, hydrogen ion is created in between the cathode and anode, that is the electrolyte. On then hydrogen is supplied on the right hand side, and excess hydrogen and the water are ejected from this, and the electricity are generated. So, this is the various type of the fuel cell. We will discuss further the applications of the fuel cell in various sectors. Thank you very much.